In this video, we will going to discuss about the types of loads acting on the beam. So what are the different types of loads acting on the beam? Number one, which is the point or concentrated load. Number two, distributed load. And number three, uniformly distributed load. Number four, uniformly variable load or varying load. And number five, the couple. So first we are going to take up the point or concentrated load. In this, a figure shows a point or concentrated load. So these are the point loads, which is W1 and W2. It is not possible to apply a load at a point. It is not possible to apply a point load at a point, as it must have some contact area. The area should be there to apply a load. But when compared to the length of the beam, so when compared to that length of the beam, this area is very small. So therefore, it has been neglected. So we have the point load, which is W1 and W2. It is more possible to apply the load at the point, but it should have some contact area. But when you are considering this contact area with respect to the length of the beam, the length of the beam is so large that the contact area can be neglected. So the second one is the distributed load. If the load acts on the beam spread over some area, if it is spreading over some area, it is called distributed load. The rate of loading, in this case, the rate of loading is not uniform. You can see the rate of loading is not uniform, which is as shown with some zigzag. It may have at some particular area, it will going to have some more load, and in some section of the area, it will going to be the less. So that is the reason why it is just called the distributed load. So that means the load is distributed over area, but it will not be of uniform in nature. Then we have the uniformly distributed load, which is called UDL. A UDL is one which is spread over a beam in such a manner that the rate of loading W is uniform along the length or axis of the beam. So that means if this is the conventional representation of the uniformly distributed load, either you can represent like this, or it can be represented like this. And here it is a simply supported beam, which has been shown here, where W is the rate of load, small w is the rate of loading, which is W per unit length, which is spread over a beam in such a manner that the rate of loading W is uniform along the length of the length or axis of the beam. So that means wherever you take the section, but the section at that point, the rate of loading will be always W. Since it is uniform throughout, therefore it is called uniformly distributed load. The next comes the uniformly varying load. If the load is spread over a beam in such a manner that the rate of loading varies from point to point along the length or axis of the beam, it is called uniformly varying load. So that means whenever you take the section, at that particular section, the rate of varying the load will be uniform. The rate of loading varies from one particular point to the another particular point. The length of the axis of the beam, it is called uniformly varying load. A varying load has an intensity that changes from W1 along the axis. For instance, the linearly varying load has an intensity that varies linearly from one end at W1 to the another end at W2, which is small w1, and at this small w2. So this is called the uniformly varying load. When the load is zero at one end and increases uniformly to the maximum at the other end, then the load is called triangular load. So that means you have the load at one end is 0 and the increases uniformly to the maximum W at the other end. And then the load is called the triangular load because the shape looks like a triangular. So that is the reason why it is called a triangular load. It can be in the other direction also. That means you can have the load at this point as 0 and the load will be maximum at this point. So this will also is valid. That means 0 at the right end and W intensity of loading at the left end will be the maximum of W. So that you're going to form the triangular load. The last one is nothing but the couple. A beam may also subjected to couple. That means the rotation of the beam. The beam has also subjected to couple, wherein you have a beam of simply supported beam having a couple at the midpoint. So having a clockwise couple which is represented by C or M. So these are all the different types of loads which is coming on the beam. Thank you.